All right, good morning, everybody. My name is Cuypers. I'm from Hyves Project Research in Oslo in Norway. And we're going to be talking about next generation agile methods and particularly agile rolling wave planning. So we'll do a short introduction, look at the literature and the methodology of the research. We'll introduce a model for project uncertainty. We'll talk about agile rolling wave planning technique to reduce uncertainty. We'll discuss quickly a case study and then the conclusions. So let's start with agile methods. Scrum was introduced in 1995. So this year, 2025, is the 30th anniversary of Scrum. So although most people will say it is a modern method, it's already 30 years old and a lot has happened. Now, Scrum was a major upgrade for project management, specifically in the software areas, but it had a number of limitations. First of all, it's software specific. Also, it's struggling with scaling as it relies on a lot of small teams. So how do you integrate and coordinate those teams? It's also struggling how to control complex projects. And the other backdrop is that it is an empirical method. So there's no theoretical foundation. It is based on observation. And that basically means that there is a lot of variation. Everybody does what they like to do because the theoretical norms and standards are missing. If you now look at the bigger picture is in project management is that we are struggling to generate a generic project success paradigm. We don't have a generic standard to determine whether a project is a success or not. And that's basically a problem because if you do not know what success looks like, how can you know that your methods are effective? The other thing is that there's no concept of project methodology. The concepts of methodology and method are used intertwined. Again, that is a serious limitation we're looking at because if you don't have a methodology project concept, how can you know again that how then are you going to study your methods and how can you know what methods are more effective or efficient in various contexts? And the final part of the bigger picture is that we have no definition of uncertainty in projects. Most people will call it risk and uncertainty. It's basically used, again, intertwined. And that is not accurate enough to control uncertainty if you do not know what it looks like. So the research question is as follows. Projects are characterized by uncertainty. You do a unique assignment and you have a lot of questions and a lot of missing information. But then again, in practical project work, there's two requirements. The management team would like to have a complete picture of the project. What are we going to do? How much time is it going to take? How much money will it cost? What benefits will I get? They want a full overall picture. But then again, a lot of that information is missing. So if you make detailed plans, those plans will be useless after a short while. There will be a gap between what you actually see and the plan. So the research question is how can we practically balance the need for accurate overall long-term planning for the management team while leveraging emerging information for creating short-term detailed plans? If you look at the literature, the concept of classic rolling wave planning is basically a staged planning approach. And mostly what is being described as, all right, yes, there will be emerging information, but you will not do detailed planning until you reach the next state, basically by passing the decision gate. It is described as iterative, so redoing tasks until the aim is achieved. It's also described in literature as progressive elaboration, meaning adding additional tasks necessary to achieve the aim. And it's also described as incremental. Although it's mentioned a lot, the practical application as how to practically do it is not very detailed described in literature. Then the methodology for this research. We've done observation on the ServiceNow implementation project, and basically the IT operation modules and the IT service management modules for Orange Business. Orange Business is an international service supplier, and the project or the program really happened in Sweden, Norway, and Germany. And the program consisted of 17 projects on a 3-year timescale and a several million euro budget. An investment was made to train the team in next generation agile team skills and project management skills. And the idea was over a 3-year timescale that will pay off. The effort was supported by 2 consultant companies, and typical activities were requirement analysis, building the platform on a dual site base. There was software development, software configuration. We had to do process design. There's organizational development to be done, testing and deployment, training, and go live. And the project management system used were mainly Jira, Confluence, and WS Pro. So as discussed, projects are characterized by uncertainty. But here's the thing, you cannot control what you cannot define. What is project uncertainty? We define project uncertainty as a combination of information awareness and information availability. Now, if the square represents all information about a project, then there's in reality 2 limits. First of all, there's information that is available and information that is not yet available. And the other limit is that there is a lot of information existing. There is information that you're aware of that's relevant, but there's also a lot of information out there. Think about the internet that simply exists, but you are not aware of its existence. That basically gives you 4 quadrants. Known, the information you're aware that it exists and it is available. And then to the right, there's the known unknown. Yeah, you know that you want to know, but it's not yet available. The unknown known basically means is that the information exists, but you're not aware of the fact that it exists. And then there's the unknown unknown. You're unaware and it doesn't exist yet. Then based on the model, there's 4 strategies to increase your known area and reduce uncertainty. First of all, increase awareness, your information awareness. Second, increase your information ability. Then effective use of the information that you have. Even if you have information, doesn't mean that you make effective use of it. And then there's the efficiency. How much time and resources does it take to get that known information on your dashboard and on your radar to make the decisions? So what you then can do is you can say projects are basically systems with elements that are connected, and there are relations between these elements, and these elements interact with each other. It's a system thinking approach. There's elements of the assignment. Project is characterized by making decisions. There's various scenarios or plans. There's the project management methods, and there's of course the context of the parent organization where the project takes place. What you then can do is you can project the uncertainty matrix over the various elements, and you can ask yourself, all right, parts of the assignment, for example, the requirements. What is known? What is known unknown, unknown, etc., etc. So that basically provides us with a theoretical model of project uncertainty. Then let's go to the practical application. Agile rolling wave planning is a practical technique used to reduce uncertainty in projects and to look forward on the long term, but at the same time do detailed planning on the short term. And it's basically based on the work it starts with the work of Chabris and Simmons, 2 psychologists that wrote the book, The Invisible Gorilla. And you might have seen these tests. What they did is they showed videos to students where they were asked to do a simple task, counting the number of passes that a baseball team was doing. And in the middle of that video, a man in a gorilla would simply pass through the scene. And the majority of the students would miss that person. So if you apply that to projects, it could be a lot of information like the invisible gorilla that is in front of your face that you're not seeing. So this is about increasing information awareness. Now, the good news was that if they warned people ahead of time that there would be a passing a gorilla, most people would complete their assignment correct and spot the gorilla. So basically, you need to ask yourself the question, all right, what information are we looking for? And we should be warned beforehand what to look for. And we do that by making a project metadata model. We create metadata of the data we would like to see. For example, decisions. Decisions are, of course, enormously important to identify them and to make the right one and to make them on time. So in the metadata model, what would we like to know about any decision? Well, is it urgent or just important? If it is important, what is the latest point in time we need to make it? Is this a global decision or a local decision? Like, Is this a local decision this will make, or will it affect other teams? Who owns the decisions? What alternatives can we choose from? What are we aiming for? Just optimizing our decision or just to satisfy? Another key question is, how can we get confirmation that we've made the right decision or the opposite? At what point in time do we say, right, we might have made the wrong decision? What are the criteria for reversing our decision? So basically, you create a project metadata model, and when you come across a decision, first of all, you log it, and then you start filling out these questions, this additional information, and that triggers you to be more aware of the information. Another example is a working assumption. We make a lot of assumptions, for example, estimates. You need to come up with a business case. You need to come up with a plan. Any estimate that we make about benefits, costs, and resources is basically a working assumption. When you make one, you need to be aware that you're making an assumption. You need to ask yourself, like, right, who owns this assumption? What is the first possible moment to verify it? How are we going to verify it? Who needs to be notified whether we are right or wrong? And which plans rely on that working assumption? And if they're wrong, what do we need to update? Another typical element is, of course, risk, problem, and crisis. When it comes to risk, we need to define the risk, of course, right? In the risk stage, we need to define preemptive measures to make sure that the risk doesn't occur, and there's the various strategies we can follow. Same goes for a problem. Once the risk evolves into a problem, what countermeasures are we going to deploy and what strategy are they relying on? If we don't solve the problem, we have a crisis. If we're not capable of solving the problem and our only option is to reduce the damage, then we have a crisis and we need to define contingency measures. So we developed what we call the compass, because it's a mental model to help us to remember. It's basically a model help us to remember what the different elements are. So we identified a number of basic metadata elements that we would like to see. In the center, you have the epics that define success in the project, decisions as discussed, deliverables, of course, progress is measured by achieved deliverables, activities we would like to see, tasks, etc., etc. And I won't drive you through that, but the compass model basically, each of these elements stands for a metadata element. The next thing you can do then is, all right, we have defined the project metadata model. The next thing we can do is a technique called Power Kanban. So you create ticket types, separate ticket types for each of your metadata models. So for example, there's a ticket type called prerequisites. Which prerequisites must be in place for this project to continue? Which constraints are we talking about? Which working assumptions have we made? Which decisions have we made or do we need to make? What problems do we have? What risks do we have, et cetera, et cetera? So what you then can do is, if you put this into a Kanban system, a Kanban platform or application, you create the different ticket types, and then you can approach your project from these different angles, and you can create dashboards. Take, for example, give me my decision dashboard, then I can look at the metrics saying, okay, how many newly decisions have been discovered and how many have we made? Now, if the number of decisions that pop up go faster than you made your decisions, then you have a problem. The next step is planning levels. Basically, we introduce 5 planning levels. The first level we call the ambition level, and that goes for the entire project. So all the epics are planned in time. And once the epics are achieved, that is a measure of success. Those epic breaks down in decisions, and those decisions, once they are confirmed, again, that's progress. The next level down is deliverables. And deliverables, once they are approved, again, that is progress. Deliverables don't create themselves. There's an activity level, typically your Gantt chart level. And when they are completed, again, that is progress. And then we have the task level, which is at the individual level of the persons. A task is defined as a one-person job. So we break our project down in ambition, decision, deliverable, activity, and task level. The planning horizon on the task level is on the daily basis, typically your daily stand-up, etc., and your sprint planning, and the ambition level is for the full project. So there is a breakdown and a roll-up. The next thing you can do is you can have different planning views. Take, for example, your ambition level. I have a number of epics. You can create a network view saying, hey, how are these epics connected? Like epic 1, we start with that one. And then epic 2 and epic 4 are independent of one another, but creating or achieving epic number 3, a prerequisite to do that is that epic 2 is achieved. And same with epic 5, number 3 and epic number 4 need to be achieved before we can start. And you can also do your epics in a Gantt view, and you can also use another view, which is called the result breakdown structure view. So you have your projects, you have your epics indicating success, and you break that down. All right, which decisions do we need to make? Which activities do we need to do? Which deliverables, and so on. So the conclusion is, if we wrap this together, at the center at the core, we have our project metadata model. What information do we want to see? Increasing information awareness. We create various ticket types for each metadata element, and that is our set of project information that you put in systems like Jira or any Kanban application. Then there's different views. Each of these ticket types can be presented in a Gantt chart or a network or a list. There's various views, and each view, of course, has its own opportunities. And then we have our different levels to look at that information and plan on different horizons. So we implemented this method in the program as discussed, and we did a number of observations. Initially, there was a lot of skepticism, but it gave way to complete adaptation. People Googled simply the method and said, well, it doesn't exist. Why should we use it? And then the answer was, well, it's an experimental. It's a next generation. So you won't find it on the internet and you won't find it in books, but have faith. The next thing what happened was that technicians endorsed the method. They adopted the method. And that was a really good indicator, because as a rule, technicians don't like projects. They want to be sitting in status meeting, explaining problems, et cetera, et cetera. They just want to work. It was actually the technicians that adopted the method and said, hey, this works. We also observed that once a team got going, there was a critical mass, and anybody that came new into the project, they simply got assimilated and adopted the method without much ado. We had better scope control because we had very much defined focus on epics and deliverables. There was also reduced chatter on Slack. The technicians said, well, normally there's a lot of question. Who knows something about this or that? Now they had the information available in the system, so there was less chatter and less question on Slack. We had proactive and formalized decision making because we had a good overview of what decisions to make. We had a record and we had a network plan, and we made those decisions in time. We also started separating between management meeting and technical meetings. In the management meeting, the problem was simply identified, a person was assigned, and then in the technical meeting, it was solved. So a lot of meetings were better structured, and they ended ahead of time. If a meeting was planned for an hour, most of the time when everything was discussed, the meeting was simply abandoned in half the time. We got some additional metrics and improved visibility in the performance. And we also got improved coordination between the 17 projects because the information existed. So this is how coordination is achieved on a project level or a program level. When you have a project, you can have different teams which all have their own assignments. In a program, you have different projects that have their own assignments. You create a result breakdown structure. And if, for example, the black boxes represent epics that need to be achieved, you can coordinate, you can visualize in a network view how these epics hang together, or decisions, or deliverables, or tasks, or activities. So you can coordinate with the different ticket types or information types and the different views. You have a better way of coordinating what is happening across multiple projects or across multiple teams. And the final question is, of course, all right, yeah, we're using a method, but are we achieving success? And this is where the project success paradigms comes into the picture. Now, this is a very basic basic picture, but I'll run you through it. There are project drivers, and the drivers are the reason why you do your project. And that basically means stakeholders need to be involved to address those drivers. Activities need to be done to create deliverables, and those deliverables cause benefits, and that provides you with an outcome or a business case. And there's a number of questions, check questions that you can ask. Once you identify a stakeholder, you can ask, right, are we going for the correct drivers? And when you deploy activities, you can ask your stakeholders, do we have the right people? And for each deliverable, there must be an activity that creates it. And you can ask yourself, is there a causal relationship between the benefits and the deliverables? And finally, you can ask yourself, are the benefits worth the cost? Now, I won't run you through the entire success paradigm, but basically this is an operational questions that you need to ask yourself all the time. Planning to support was found to be very limited. Current systems, typically like Jira or ServiceNow DevOps and these type of applications, or Monday.com, they have limited views. It's mainly list views, Kanban boards, and maybe some Gantt charts. And there is no breakdown possibility to break your tickets down into a hierarchy. So the future, Agile Rolling Wave Planning provides an input for future AI-supported development. Basically, the first step would be to define a project metadata model in your tool. And then secondly, you would like your tool to troll to any type of project information to identify project metadata elements. Next step is then to discover the relationship between these elements, then visualize, like for example, a network chart, then start making recommendations. Finally, assess project performance and preferably forecast the outcome. So finally, the conclusions. So first of all, using systems thinking approach, we can define project uncertainty by projecting the uncertainty matrix over a systems thinking model. Based on that model, we can then say, all right, there's 4 uncertainty reduction strategies to increase information awareness, availability, the effective use of the information, and also the efficient use of the information. That is the theoretical foundation. Then we go over to practice. How do you do that in practice? How do you do that in the field in real life? So first of all, there's project metadata technique. By designing beforehand the project metadata model, what to look for, you are triggered. You can spot that information more easier. And this can be leveraged by using AI. And then by using a multi-level and multi-horizon planning framework with different information views, you provide a framework for any emerging information that comes up to put it into the right wave, into the right level, and into the right ticket type, and into the right plan. Then Agile Rolling Wave Planning, it then creates a balance between, yes, there is a long-term overall information need at a high level, but there's also a short-term need. And the other conclusion is that current project software provides very limited support, and there's room for improvement. Any questions?